Hello my grade 9 students! Welcome to my video lesson. I am Mitch Biduya, your Math 9 teacher. And now, we are in the 4th week of the first quarter. The learning competency that you are going to learn: solve problems involving quadratic equations and rational equations. The code: Math 9, Algebra, first quarter, 4th week, first lesson. These are the objectives that you are going to learn. First, translate verbal statements into mathematical statements. Second, solve problems like geometry, number relations, projectile motion, work, distance, age, and other miscellaneous problems involving quadratic equations and rational algebraic equations. Third, show perseverance and dedication in solving problems involving quadratic and rational algebraic equations. The lesson for this week is solving problems involving quadratic equations. In this lesson, we are dealing with word problems. What is a word problem? It is a description of a situation that involves both known and unknown quantities and relationships between them. Many problems give rise to quadratic equations. The concept of quadratic equations is illustrated in many real-life situations, such as number 1, involving number relation. Number 2, geometry. Number 3, distance. Number 4, work. Number 5, profits. Number 6, age. 7, projectile motion. And many others. This can be solved by applying the different mathematical concepts and principles previously studied, including quadratic equations and the different ways of solving them. Many word problems involving unknown quantities can be translated to quadratic equations. Now, we will learn how to frame the equations or translate to mathematical statements from word problems. So let us recall the terms or some word or phrases to unlock difficulties. There are some keywords you need to remember in translating verbal statements to mathematical statements. First, consecutive integers represent x, x plus 1, x plus 2, and so on, where x is any integer. Example of this integer: if x is 5 or the first integer is 5, to obtain the next integer, you add 1 to 5. So that is equal to 6. And to get the third integer, we add 2 to 5. So the third integer is 7. Thus, the three consecutive integers are 5, 6, and 7. Take note that there are positive and negative integers. Number 2, even or odd integers. So if consecutive, even or odd integers, the pattern is x, x plus 2, x plus 4, where x is any even or odd number. Example of this number is 11. 11 is an odd number. Next to 11 is 13. It is also an odd number. We add 2 to 11 to get 13. And next add number to 13 is 15. From 11 to 15, we add 4 to 11 to get 15. Thus, 11, 13, and 15 are 3 consecutive odd numbers. Number 3, sum means add. Next, number 4, product means multiply. Number 5, more than or increase means add. Number 6, less than or decrease means subtract. Number 7, twice, thrice, or 4 times means multiply. So if it is twice, multiply the number by 2. If it is thrice, multiply the number by 3. Or if it is 4 times, multiply it by 4. Number 8, square of a number means a product of some integers and itself. Or written as n squared, where n is any real number. In some problems, there are multiple operations involved. Thus, you need to familiarize all the words that corresponds to the operation being illustrated. Number 9, reciprocal. To get the reciprocal of a whole number, divide 1 by the number. Or, if it is a fraction, just turn it upside down. Examples. If the number is 23, so what is the reciprocal? Yes, the reciprocal is 1 over 23. Next, if the number is 5/3, what is the reciprocal? Yes, the reciprocal is 3/5. Number 10, formulas. I said earlier, there are problems like geometry illustrate quadratic equations. Thus, we need to recall some geometric formulas that you learned from your previous lessons. Like area of a rectangle, that is equal to length times width. A square is a rectangle, so the area is equal to side times side, or s squared, since the length of the width are the same. Next, area of a triangle, that is equal to base times height over 2. Another formulas like distance, rate times the time. Next, rate is equal to distance over time. And to find for the time, that is equal to distance over the rate. There are also another words that you need to recall, like upstream, means moving or traveling against the current. Another word, downstream, means moving or traveling with the current or in the same direction as the current. The following are the steps that can help you translate the word problems to equations. So here are the steps. First, read and understand the problem. Second, identify the quantities, both known and unknown, that are involved in the problem. Third, write let statement or assign a variable to represent a quantity that is being sought. Then use the variable to write expressions for other quantities. Next, fourth, Draw or sketch the situation if necessary. Number 5, write an algebraic equation to represent the situation. Here are some illustrative examples. So let us translate the following verbal statement to algebraic equations. So let's start with geometry problems. Number 1. The area of a concrete rectangular pathway is 350 square meters and its perimeter pathway is 90 meters. What is the length of the pathway? Number 2. A rectangular lot has an area of 240 square meters. What is the width of the lot if it requires 64 meters of fencing materials to enclose it? Number 3. The base length of a triangle is 2 centimeters more than its height. The area is 24 square centimeters. Find the base. Number 4. The length of a tarpaulin is 3 feet more than thrice its width, and the area is 126 square feet. What is the length of the tarpaulin? So let us start translating situation number 1. Solution. The unknowns here are the length and the width of the rectangular pathway, and the known are the perimeter and the area of the rectangular pathway. So we will let L be the length of the pathway, and we will let W be the width of the pathway. Then the area of the rectangular pathway is 350 square meters, and the perimeter is equal to 90 meters. Then, let us draw the diagram and label the information. If this is the rectangular pathway, so this is the length, the width, and the area. So the area is the measure of the surface of a given figure. And the perimeter is the distance around a given figure. So this is the perimeter. So the perimeter is 90 meters. Write the equation using the perimeter and area. By substitution, the formula for the perimeter is 2 times the quantity of length times width, or 2 times the quantity of L plus W. Substitute 90 to perimeter. So 90 is equal to 2 times L plus W. So by division property of equality, we will divide both sides of the equation by 2. So 90 divided by 2 is equal to 2 times the quantity of L plus W over 2. So the equation becomes 45 equals L plus W. If we are going to solve W in terms of L, so we have W equals 45 minus L. Then, the formula for the area is length times width, or area is equal to L times W. We substitute 350 to the area. Now, the equation becomes 350 equals L times the quantity of 45 minus L. So, we substituted 45 minus L to W. So, the equation now becomes 350 equals negative L squared plus 45L. In standard form, the equation is now L squared minus 45L plus 350 equals 0. So we'll read it translated. Situation number 1, two mathematical equation. Another way of deriving the equation is by using the sum and product of the roots of a quadratic equation. So here is the solution. Letter A, write let statement. We will let W be the width or one of the roots of a quadratic equation, and L be the length or the other root of the quadratic equation. So we use the concept of product of roots. So the product of roots means the area or length times width. So that is equal to 350 square meters. Then the sum of roots means the half of perimeter or length plus width or L plus W. So that is equal to 90 meters. So in writing the equation, the quadratic equation given the sum and product of roots is x squared minus sum of roots x plus product of roots equals 0. Then substitute x is equal to L. So the equation is L squared minus 45L plus 350 equals 0.
Therefore, L squared minus 45L plus 350 equals 0 is the translated equation to find the length of a concrete rectangular pathway. Second situation, a rectangular lot has an area of 240 square meters. What is the width of the lot if it requires 64 meters of fencing materials to enclose it? Solution: let x be the width of a rectangular lot. Then the area of a rectangle is equal to 240 square meters. Then the perimeter of a rectangle is equal to 64 meters. Then, by using the sum and product of roots of a quadratic equation, so we have x squared minus sum of roots x plus product of roots equals 0. Then, the equation is now x squared minus 32x plus 240 equals 0. Therefore, the equation to solve the width of a rectangular lot is x squared minus 32x plus 240 equals 0. The third situation, the base length of a triangle is 2 centimeters more than its height. The area is 24 square centimeters. Find the base. The solution, let x be the height of a triangle and x plus 2 be the base of a triangle. Then, when we draw this triangle, this is the height, then the base. When we substitute this to the formula of the area of a triangle, so the equation is 24 equals x times the quantity x plus 2 over 2. By multiplication property or by cross multiplication property, that is 24 times 2 is equal to 48. Then distributive property, so equals to x squared plus 2x or x squared plus 2x equals 48. Then the standard form of this equation is x squared plus 2x minus 48 equals 0. Therefore, the equation to solve for the base of a triangle is x squared plus 2x minus 48 equals 0. Situation number 4. The length of a tarpaulin is 3 feet, more than thrice its width, and the area is 126 feet squared.
What is the length of the tarpaulin? So here's the solution. Let Z be the width of the tarpaulin. And 3Z plus 3 be the length of the tarpaulin. Next, substitute. So we have Z times the quantity 3Z plus 3 equals 126. By distributive property, so the equation becomes 3Z squared plus 3Z equals 126. So in standard form, the equation is now 3Z squared plus 3Z minus 126 equals 0.
Reduce the equation by dividing 3 to each terms of the equation. So the equation becomes Z squared plus Z minus 42 equals 0.
So therefore,
the equation to solve for the length of the tarpaulin is x squared plus Z minus 42 equals 0.
Another illustrative examples. So again, we will translate the following verbal statement to algebraic equations. The problems here involve number relations. Number 5. The sum of two numbers is 12 and their product is 35. What are the two numbers? Number 6. The product of the two consecutive even integers is 840. Find these numbers. So here's the solution, situation number 5. In this case, we consider the sum of two numbers is the sum of the roots of a quadratic equation, and their product is the product of its roots. So we can substitute from the concept. So x squared minus sum of roots x plus product of roots equals 0. So we have x squared minus 12x plus 35 equals 0. So therefore, the equation to solve the two number is x squared minus 12x plus 35 equals 0. Number 6. The product of two consecutive even integers is 840. Find these numbers. So we will let x be the first even integer and x plus 2 be the second integer. So here's the equation. So x times the quantity x plus 2 equals 840. By distributive property, we have x squared plus 2x equals 840. So the standard form is now x squared plus 2x minus 840 equals 0. Therefore, the equation to solve the two consecutive even integers is x squared plus 2x minus 840 equals 0. You know already how to translate word problems to mathematical equations. And you are now ready to solve word problems involving quadratic equations. Let's recall first the four methods of solving quadratic equations. Number 1, factoring. Number 2, extracting square root. Number 3, completing the square. Number 4, quadratic formula. Here are the steps in solving word problems. First, read and understand the problem. Second, identify the quantities, both known and unknown, that are involved in the problem. Third, write let statement or assign a variable to represent a quantity that is being solved. Then use the variable to write expressions for other quantities. Fourth, draw or sketch the situation if necessary. Number 5, write an algebraic equation to represent the situation. Number 6, solve the equation. 7, answer the question asked in the problem. Number 8, check the solution in the original problem. So let's start solving problems involving geometry. Example number 1, the area of a concrete rectangular pathway is 350 square meters and its perimeter pathway is 90 meters. What is the length of the pathway? Solution number 1. The unknowns here are the length and the width. And the knowns here are the area and the perimeter. So we will let x be the width and y be the length. So the perimeter is equal to 2 times the quantity x plus y equals to 90 meters. Use the perimeter of deriving y in terms of x. So we have 2 times the quantity x plus y equals 90. By division property of equality, we have 2 times the quantity x plus y over 2 equals 90 over 2. So x plus y equals 45. So we will solve for y. So y equals 45 minus x. Then substitute to the area. So y equals 45 minus x. So the area is x times y. So that is equal to 350. X times the quantity 45 minus x equals to 350. Then by distributive property, we have 45x minus x squared equals 350. So the standard form is negative x squared plus 45x minus 350 equals 0. We're going to multiply negative 1 both sides of the equation. To make the first term of the quadratic equation positive, or the leading coefficient is positive. So we have x squared minus 45x plus 350 equals 0. So we can now solve this quadratic equation. So by factoring method, we can solve this equation. The equation is now the quantity of x minus 35 times the quantity of x minus 10 equals 0. So by zero product property, we will equate each factor to 0. Or x minus 235 equals 0. Or x minus 10 equals 0. So let us solve. X is equal to 35 or x is equal to 10. We are going to check if our solutions can really satisfy the equation. So we have 35 squared minus 45 times 35 plus 350. Is it equal to 0? 1,225 minus 1,575 plus 350. Is it equal to 0? 1,225 minus 1,225. Is it equal to 0? Yes, 0 is equal to 0. Or, if x is equal to 10, so let us substitute from the equation. So 10 squared minus 45 times 10 plus 350. Is it equal to 0? 100 minus 450 plus 350, is it equal to 0? So 1,225 minus 1,225, is it equal to 0? Yes, 0 is equal to 0. Since the width is 35 or 10 meters, therefore, the length is 10 or 35 meters respectively. Solution number 2, use the concepts of sum and product of roots of a quadratic equations. Area is equal to product of roots, that is equal to 350. Half of perimeter is equal to sum of roots, that is equal to 45. So by applying the concept of sum and product of roots of a quadratic equation, so we have x squared minus 45x plus 350 equals 0. So this is now the quadratic equation in standard form. So the solutions are x equals 35 or x equals 10. Example number 2. The area of a garden is 152 square meters. Suppose the length of the garden is 3 meters, more than twice its width. Find the dimensions of the garden. The unknowns here are the dimensions of the garden. And the known is the area of the garden. So, here's the solution. Let x be the width and 2x plus 3 be the length. So, area is equal to x times the quantity 2x plus 3. The equation is now x times the quantity 2x plus 3 equals 152. By distributive property, we have 2x squared plus 3x equals 152. So the standard form is 2x squared plus 3x minus 152 equals 0. By factoring method, so the equation, the quantity 2x plus 19 times the quantity x minus 8 equals 0. So let us solve. So we have x equals negative 19 halves or x equals 8. Let's solve for the length. Since the width cannot be negative, we will only take positive 8 as the value of x. So we have 2x plus 3 equals 2 times 8 plus 3 equals 19. So the dimensions of the garden are 8 meters, that is the width, and 19 meters, the length. Next is solving problems involving number relation. Number 3 example, the sum of two odd numbers is 12 and their product is 35. What are the two numbers? So here's the solution. Let x be the first integer. X plus 2 be the second integer. Their product is equal to x times the quantity x plus 2. So the equation is now x times the quantity x plus 2 equals 35. By distributive property, so the equation is x squared plus 2x equals 35. To write the equation in standard form, so we have x squared plus 2x minus 35 equals 0. So by factoring method, the equation is now the quantity x minus 5 times the quantity x plus 7 equals 0. So let us solve. So x equals 5 or x equals negative 7. Therefore, x is equal to 5 or negative 7. Thus, x plus 2 equals 7 or negative 5. And the numbers are 5 and 7 or negative 5 and negative 7. Since the sum of two numbers is 12, hence, the only two numbers are 5 and 7. Solution number 2. Applying the sum and product of roots of quadratic equation, which is x squared minus sum of roots x plus product of roots equals 0.
So the equation is x squared minus 12x plus 35 equals 0. Then, by applying the factoring method, the factored form is x minus 5 times the quantity x minus 7 equals 0. Then, the solutions are x equals 5 or x equals 7. Therefore, the two odd numbers are 5 and 7.
Solution number 2 is the shortcut way in finding for the two numbers. Reminders in solving consecutive integer problems. Here are the steps in solving problems involving consecutive integers. Write let statement. If consecutive integers, use x, x plus 1, x plus 2, and so on. If even or odd, use x, x plus 2, x plus 4, and so on. Then write the equation using keywords from statements such as sum, add, product, multiply, more than, add, less than, subtract. Then check the original statement. Next is problem involving projectile motion. What is a projectile? A projectile is an object that rises that falls under the influence of gravity, and projectile motion is the height of that object as function of time. Projectile motion can be modeled by a quadratic equation. The formula to model the height of an object t seconds after it has been thrown is h equals negative 16t squared plus v sub 0 plus h sub 0, where h equals height or altitude, t equals time in seconds, v sub 0 is the initial velocity, and h sub 0 is the initial height. The formula to model the height of an object t seconds after it has been dropped is h equals negative 16t squared plus v sub 0 plus h sub 0, since v sub 0 is equal to 0. Okay, example. A projectile that is fired vertically into the air with an initial velocity of 120 feet per second can be modeled by the equation h equals 120t minus 16t squared. In the equation, h is the distance in feet of the projectile above the ground after t seconds. Question letter A. How long will it take for a projectile to reach 216 feet? Question letter B. Is it possible for the projectile to reach 900 feet? Justify your answer. So here's the solution. Letter A. So we will use the given equation. H is equal to 120t minus 16t squared. Since h is equal to 216, so we will substitute 216 to h. So the equation is now 216 equals 120t minus 16t squared. We will change the equation to standard form. So the equation is now 16t squared minus 120t plus 216 equals 0. By applying the division property of equality, we will divide both sides of the equation by 8. So we have 2t squared minus 15t plus 27 equals 0. To solve this equation, we use the quadratic formula. So we have a is equal to 2, b is equal to negative 15, c is equal to 27. By substituting the values of a, b, and c from the quadratic formula, we have t equals negative times negative 15 plus minus square root of negative 15 squared minus 4 times 2 times 27 all over 2 times 2. Then, t equals 15 plus minus square root of 225 minus 216 all over 4. So, t equals 15 plus minus square root of 9 all over 4. That is equal to 15 plus minus 3 all over 4. The first solution is t equals 15 plus 3 over 4. So, t equals 18 over 4 equals 9 halves. Or, the second solution, t equals 15 minus 3 all over 4. So, we have t equals 12 divided by 4 is 3. Therefore, the time it takes the projectile to reach 216 feet is 3 seconds or 4.5 seconds. Letter B problem. Is it possible for the projectile to reach 900 feet? Justify your answer. So here's the solution. So we will use the given equation. H is equal to 120t minus 16t squared. So we will substitute H to 900. So the standard form of the equation is now 16t squared minus 120t plus 900 equals 0. In this problem, we use the concept of discriminant. But before that, let us have the values of A, B, and C. A is equal to 16, B is equal to negative 120, and C is equal to 900. So the discriminant is equal to B squared minus 4AC. So let us substitute. The discriminant is negative 120 squared minus 4 times 16 times 900 equals 14,400 minus 57,600. So that is equal to negative 43,200. Hence, the answer is no, because the discriminant of the resulting equation is negative, meaning it is not a real number. Next is solving age problem. Example number 4. Ramon's age is 1 more than twice Mary's age. In 2 years, the sum of the squares of their ages is 289. How old is each? So here's the solution. Let x be Mary's present age and 2x plus 1 be Ramon's present age. X plus 2 be Mary's age in 2 years. And 2x plus 3 be Ramon's age in 2 years. So here's the equation to solve the problem. The quantity x plus 2 squared plus the quantity 2x plus 3 squared equals 289. Since the left side of the equation has 2 square of a binomial, so we can transform this to perfect square trinomial. So we have x squared plus 4x plus 4 plus 4x squared plus 12x plus 9 equals 289. So by combining like terms, x squared plus 4x squared plus 4x plus 12x plus 4 plus 9 equals 289. The equation becomes 5x squared plus 16x plus 13 equals 289. We transform the equation to standard form. So 5x squared plus 16x plus 13 minus 289 equals 0. Then combine 13 and negative 289. So the equation is 5x squared plus 16x minus 276 equals 0. So by using the quadratic formula, we can solve the equation. So we have A is equal to 5, B is equal to 16, C is equal to negative 276. So let us substitute the value of A, B, and C to the quadratic formula. So x is equal to negative 16 plus minus square root of 16 squared minus 4 times 5 times negative 276 all over 2 times 5. So x equals negative 16 plus minus square root of 256 plus 5,520 all over 2 times 5. So x is equal to negative 16 plus minus square root of 5,776 over 10. Now, since 5,776 is a perfect square, square root of 5,776 is 76. So the equation is now x equals negative 16 plus minus 76 all over 10. So the first solution, or x sub 1, equals negative 16 plus 76 over 10. So equals 60 divided by 10 equals 6. Or the second solution, or x sub 2, x equals negative 16 plus minus 76 over 10. So equals negative 92 over 10 equals negative 46 over 5. We take the positive value of x because x represents age. We take the positive value of x because x represents age. By substitution, the present age of Mary is x equals 6. And present age of Ramon is 2 times 6 plus 1 equals 13. Let us check if our solutions are correct. So x plus 2 equals 6 plus 2 equals 8. So that is the age of Mary in 2 years. Then 2x plus 1 plus 2 equals 2 times 6 plus 3 equals 15. That is the age of Ramon in 2 years. So 8 squared plus 15 squared, is it equal to 289? 64 plus 225, is it equal to 289? 289 is equal to 289. Therefore, Mary is 6 years old and Ramon is 13 years old. Next is solving miscellaneous problem. Here's the example. If an amount of money P in pesos is invested at R% compounded annually, it will grow to an amount A equals P times the quantity 1 plus R squared in 2 years. Suppose Mrs. Biduya wants her money amounting to 200,000 pesos to grow to 228,980 pesos in 2 years. At what rate must she invest her money? Okay, here's the solution. The equation to solve this problem is A equals P times the quantity 1 plus R squared. Then substitute. So A is equal to 228,980 pesos equals to 200,000 pesos. So that is the principal amount times the quantity 1 plus R squared. So by division property of equality, we will divide both sides of the equation by 200,000 pesos. So the equation is now 1 and 1,449 10,000ths equals the quantity of 1 plus R squared. Square root both sides, we have 1 and 700ths equals 1 plus R, or 1 plus R equals 1 and 700ths. To solve for R equals 1 and 700ths minus 1. So R equals 700ths. Or in percentage, R equals 7%. Therefore, Mrs. Biduya invested her money with a rate of 7%. Our next goal is solving problems involving rational algebraic equations transformable to quadratic equations. So there are real-life problems that involve rational algebraic equations such as a number relation, work, navigation, engineering, motion, and physics. The problems here are number relation problem, work problem, and distance problem. Here's an example of number relation problem. Number 6. I am thinking of a number. If I add this number to its reciprocal, the result is 13/6. Find all such numbers. Solution. Let x be the number. Then, 1/x be the reciprocal. So the equation to solve the numbers is x plus 1/x equals 13/6. To eliminate the denominators, we will apply the multiplication property of equality. So the LCD is, or the LCM is 6x. So we multiply both sides of the equation by 6x. So we have 6x times the quantity x plus 1/x equals 6x times 13/6. So by distributive property, we have 6x squared plus 6 equals 13x. The standard form of the equation is 6x squared minus 13x plus 6 equals 0. To solve this equation, we use factoring method. Since the leading coefficient is greater than 1, So we multiply the leading coefficient to the constant. So 6 times 6 equals 36. And then we find two factors of 36 wherein the sum of the two factors is equal to the coefficient of the second term of the equation. So what are the two factors of 36? Yes, the two factors of 36 are negative 9 and negative 4. Because negative 9 plus negative 4 equals negative 13. So that is the value of the coefficient of the second term. Then, the equation is now the quantity 6x minus 9 times the quantity 6x minus 4 equals 0. Then, we divide 6 to both sides of the equation and factored out the numerator. So, the numerator is now 3 times the quantity 2x minus 3 times 2 times the quantity of 3x minus 2 over 6 equals 0. So, we have 3 times 2 is equal to 6. So, 6 divided by 6 is equal to 1. So, the equation now becomes the quantity 2x minus 3 times the quantity 3x minus 2 equals 0. By applying the zero product property, we have 2x minus 3 equals 0 or 3x minus 2 equals 0. X is equal to 2/3 or x is equal to 3/2. Then we're going to check if we add the number and its reciprocal, is it equal to 13 over 6? So let's find out. If the number is 2/3, then its reciprocal is 3/2. So if we are going to add 2/3 plus 3/2 equals 2 times 2 plus 3 times 3 over 6. So 6 is the LCD because we are adding the similar fraction. So that is equal to 4 plus 9 over 13. So equals to 13 over 6. The sum of the number 2/3 and its reciprocal 3/2 is equal to 13 over 6. Therefore, the two numbers are 3/2 and 2/3. Next is work problem. In solving a work problem, use the following guide. 1 over t sub 1 plus 1 over t sub 2 equals 1 over t sub t, where 1 over t sub 1 is the part of the job done by A, and 1 over t sub 2 is the part of the job done by B. Then 1 over t sub t is the total time spent when A and B work together. Here's an example. The brothers Anthony and Antonio were asked by their mother to disinfect the whole areas of their house to make their house free from COVID-19 virus contamination. If it takes Anthony 10 more minutes than Antonio can do alone, but together they can disinfect the whole house in 12 minutes. How long can Anthony disinfect the whole house alone? So here's the solution. Let x be the time it takes for Antonio to finish the work alone. Then x plus 10 be the time it takes for Anthony to do alone. So here's the equation to solve the problem. So 1 over x plus 1 over x plus 10 equals 1 over 12. The formulated equation was a rational algebraic equation. So To solve this rational algebraic equation, we find first the LCD. So what is the LCD? Yes, the LCD is x times the quantity x plus 10. So we have x plus 10 plus x all over x times the quantity x plus 10 equals 1 over 12. Combine like terms, 2x plus 10 over x squared plus 10x equals 1 over 12. By cross multiplication properties, we have 24x plus 120 equals x squared plus 10x. Then, by transposition method, we transfer all the terms in the right side to the left side of the equation. So we have x squared plus 10x minus 24x minus 120 equals 0. Then, the standard form is x squared minus 14x minus 120 equals 0. So we can now solve the equation. So by factoring method, the equation is now the quantity of x minus 20 times the quantity x plus 6 equals 0. By applying the zero product property, we have x minus 20 equals 0 or x plus 6 equals 0. So x equals 20 or x equals negative 6. Since the time cannot be negative, we use 20 as the value of x. Solving for Anthony's time, substitute 22x from x plus 10 equals 0. So, 20 plus 10 equals 30. Therefore, the time it takes for Anthony to finish the work alone is 30 minutes. Next, problem number 9. This problem involves distance. In driving to Manila, a distance of 540 kilometers, a motorist discovered that he could make the trip via expressway in 2 hours, less time by increasing his speed by 9 kilometers per hour. What was his original speed? So here's the solution. Let x be the original speed. Based on the presented table, if the motorist uses ordinary road, his distance was 540 kilometers. Then the rate is x. That will be the original speed. Then the time it takes for him was 540 over x, because the formula for time is distance over the rate. Next, if the motorist uses expressway, his distance traveled is 540 kilometers. Then the rate was x plus 9. Then the time, that is 540 over x plus 9. So the equation to solve the problem is 540 over x minus 2 equals 540 over x plus 9. We equate the time of the motorist when he uses the ordinary road and the expressway. So let's solve the equation. So the LCM is x times the quantity x plus 9. So by applying the multiplication property of equality, we multiply both sides of the equation by the LCM. So x times the quantity x plus 9 times 540 over x minus 2 equals 540 over x plus 9 times x plus 9. So we have 540 times x plus 9 minus 2 times x plus 9 equals 540x. The standard form is 2x squared plus 18x minus 4,860 equals 0. Next, we reduce the equation by dividing 2 to each terms of the equation. So we have x squared plus 9x minus 2,430 equals 0. So by factoring method, we solve the equation. So the equation is now the quantity x plus 54 times the quantity x minus 45 equals 0. Let us solve. X equals negative 54 or x equals 45. Therefore, the original speed of the motorist is 45 kilometers per hour. Example number 10. The boat makes a trip 4 kilometers upstream against a 3 kilometer per hour current and returns to the jetty from which it started. If the round trip takes 1 hour, what speed does it go in still water? So the solution is, let x be the speed of the boat in still water. So here's the table. When the boat goes to the current, the distance was 4 kilometers. The rate was x plus 3. And the time was 4 over x plus 3. When the boat against the current, the distance was 4 kilometers. The rate was x minus 3. And the time was 4 over x minus 3. So the equation to solve the problem, so we have 4 over x plus 3 plus 4 over x minus 3 equals 1. So the LCM is equal to the quantity x plus 3 times the quantity x minus 3. So we have the equation. So x plus 3 times x minus 3 times 4 over x plus 3 plus 4 over x minus 3 equals 1. Next, 4 times the quantity of x minus 3 plus 4 times the quantity x minus 3 equals the quantity x plus 3 times the quantity x minus 3. So we have 4x minus 12 plus 4x plus 12 equals x squared minus 9. So x squared minus 8x minus 9 equals 0. So this is the standard form of the equation. Then let us solve the equation. So by factoring method, we have the quantity of x minus 9 times the quantity x plus 1 equals 0. X equals 9 or x equals negative 1. Therefore, the speed of the boat in still water is 9 kilometers per hour. Here are some important points to remember. There are real-life problems that can be solved through quadratic equations. The steps in solving word problem are: read and understand the problem. Identify the quantities, both known and unknown, that are involved in the problem. Write let statement or assign a variable to represent a quantity that is being solved. Then use the variable to write expressions for other quantities. Then, draw or sketch the situation if necessary. Next, write an algebraic equation to represent the situation. Then solve the equation. Answer the question asked in the problem. Check the solution in the original problem. This is the end of our 4th week lesson. Thank you for watching my video and God bless. Stay safe. Bye-bye.